Hello guys, in this video we've got a question. It says use calculus to find the x coordinates of the turning points of the curve y equals x cubed minus 6x squared minus 15x. Then it says hence find the set of values of x for which x cubed minus 6x squared minus 15x is an increasing function. Okay. So quite a few ways we can go about doing this. Well, first of all, to work out the turning points, we know that you can do dy dx, especially when it says use calculus, which equals 3x squared minus 12x minus 15. And to work out the turning points, we want dy dx to be equal to 0. So let me just write that to make that clear. For our turning points. Therefore, dy dx, which was equal to 3x squared minus 12x minus 15 to equal 0. Well, it's a quadratic. We can divide everything through by 3. That's quite nice to spot. So that becomes x squared minus 4x minus 5, which equals 0. And then we can factorize this into x minus 5 and x plus 1. Two numbers that multiply to give minus 5 and add to give minus 4, that's minus 5 and plus 1. So therefore, x equals 5, x equals minus 1. Cool. So those are the x coordinates of the turning points. Now, hence find the set of values for which it's an increasing function. Well, an increasing function means a positive gradient, right? Increasing function means positive gradient. So we know increasing function implies that dy dx is greater than 0 because it's a positive gradient. Our gradient function was indeed 3x squared minus 12x minus 15, and we want that to be greater than 0. Our division by 3 still follows, so we can still say that x squared minus 4x minus 5 is greater than 0. And of course, we can factorize this, as we did before, into x minus 5 and x plus 1 to be greater than 0. And we knew that our critical values were at 5 and minus 1. That's when it equals 0. Anytime you're solving a quadratic inequality, guys, we're always going to sketch a graph. If you do not sketch a graph, you will most likely get the question wrong. So quadratic, it goes through the points on the x-intercept at minus 1 and 5. So there are critical points. So it's positive, so it's going to be a smiley face, something like that. And where it's greater than 0, I'm going to actually put this in a different color. We want it above the horizontal axis. So here, and this is to the left of minus 1. So that's when x is less than minus 1. And also over here, it's where it's above, and that's where x is to the right of 5. So we say or x is greater than 5. Okay? And then I've noticed as well that some people get confused with the other notation that they may have seen. So if it's less than minus 1, that means it goes from minus 1, well, not actually minus 1, but less than minus 1 all the way down to negative infinity. So the notation would be that x is in an element of this set. So it's going to be minus infinity all the way up to, but not including, minus 1. Or we use the union symbol from 5, remember not including, so we use a round bracket, all the way up to positive infinity. If it included 5, it would have been a square bracket. If it included -1, it would have been a square bracket on the side of the numbers. Okay, but it's like that. That's it for this video.